Hello! So this is the second video on the first and second derivative test. This video is broken up into two because it was quite a lot to deal with these functions, and we're going to get to number 3 in class, so you'll see that one there. But this video is about the second derivative test and how to use that to determine where a graph is concave up or concave down, and where a point of inflection could be. So with the first derivative test, we have critical points. We don't necessarily have critical points for the second derivative test. We're just going to be able to figure out if there is a point of inflection or not. We know we can't have point of inflections on, well, we might have a point of inflection on the ends of these intervals that we're given here. So from 0 to 2, and then we're not using, I erased 3 and we're using 5. But we are going to be using -3 to 1 for the interval here on number 8, just like we did for the first derivative. So on number 7, we are going to be finding the x intervals where each function is concave up or concave down, and we'll decide if there's a point of inflection there as well. So for number 7, we're going to take the derivative of this linear function, and thankfully with polynomials our life gets a lot easier once we start to take multiple derivatives. With these rational functions, however, they get a little bit more challenging, so we'll talk about that one. But we've got the derivative of 8x is just 8. So for number 7, on 0 to 2, it looks like our second derivative is just this flat line. So this equation is the y value is equal to 8. So this is a horizontal line. So this means, this means our second derivative is positive. So that means f of x increases, or sorry, I'm sorry, is positive, so it's concave up on the entire interval 0 to 2. So let's go back and look at the function that this came from, just to double check. So this came from number 1, which is a quadratic that is upward facing, so that tracks with what the quadratic is doing. I know that the end behavior is telling me both ends are pointed up and it's a U shape, so of course it's going to be concave up. But everything we're seeing here is tracking, so this is positive. Yay! Now for a little bit more of a challenge, let's look at number 5, which need to get rid of this number here. It's 5 that we're working with on number 8. And in order to get this one, we've got to take the derivative of this rational function. But I'm going to rewrite this one first. So let me actually move this here. So I'm going to rewrite, oops, and f prime of x, sorry, my mouse is slow, and I'm going to have 2/3 x plus 1 to the -1/3. Then I can use, instead of using the quotient rule, I can use the chain rule. And I want to take the -1/3, multiply by 2/3, so get -2/9 x plus 1 to the -4/3, and then the derivative of the inside, which is 1, so that's great. But then this is equal to, so I'll just write 1 out there for continuity's sake. So this is equal to negative 2 in the numerator, and then over 9 times x plus 1 to the 4/3. We are going to try and apply the second derivative test to it. So now that I've got it here, I'm going to set it equal to 0. And if you remember, there was something funky that happened with this function in number 5. There was, for the same reason that we're going to get an undefined value when x is equal to -1, so x can't be -1 on the original function, or it's undefined at -1. We're going to get the same situation here. So if we look back at the first derivative test, we see that x can't be -1 here. So we know something funky is happening on this graph at -1. We are told that it's a critical point just based on what a critical point is doing. That's when f prime of x is undefined. It's when we don't have a slope to reference. So if we don't have a slope to reference, that doesn't mean we've got a change in increasing or decreasing. It just means there's a split in our interval. So in the same way, it doesn't mean that we are changing concavity if we've found a spot where we have an undefined second derivative. So if we have an undefined first or second derivative, that means we've got a split in our interval. For this, it could mean that we've got a change in concavity, but undefined really means, again, we just have a split. So what we need to check on now is our interval. So I'm going to put this little work over here, and we're going to check on this interval that we were working with now. It was kind of easy to work with, so I didn't have to draw a line for number 7 there, but I'm going to draw a line here at -1, and then from -3 to 1. Yeah. So if I check inside -3 to -1, I'll choose -2, and then from -1 to 1, I'll choose 0. So let's see, f double prime of -2, what's that going to be? And what's f double prime of 0? What's that going to be? It should be easy for 0. Let's see, we've got 1 to the 4/3, which is just 1, so 9, so -2/9. And then if I choose -2, I get -1, and -1 to the 4/3, well, I've got -1 to the cube root is going to be -1, and then to the 4th power is going to be +1, so another -2/9. And I'm just trying values, so I'm plugging in -2 into x here, into my second derivative, and I'm plugging in 0 into my second derivative to try those out, and that's how I'm getting -2/9. So that means this function is negative. So you might see, if you've watched other videos about this, like sine charts and stuff like that, this means that we're concave down for both sections of this interval. So we're concave down from -3 to -1, but we're not including -1. -1 to 1. So if we go and look at this graph, you can see why it is that way. And graphs are going to help you a lot for this. We have concavity to -1, and then we have a cusp, and then it continues out from there. So that's going to be really it for the notes on this one. The practice here, are, and I realize that these are marked incorrectly, I'm sorry. This should be 10 and 11. But I would like you to label these things. Like I've got them labeled, so the blue graph is 1, the red graph is 2, and then down here there was a section that this was outlined in pink, and then there was another pink section here. If you could just kind of scribble that out or ignore that, that'll help you get these graphs. That's not meant to be there. It's just supposed to be this orange graph. And then for 12, if you could change the constant there to 12, that would be great. And I hope you get this and watch this far in the video so that you're sure of how to do these things. So 12 and 13 are going to be like the problems we just did, where you'll have to use your go through the first derivative and the second derivative. So you're not taking just one derivative here, you're taking two, because it was nice in this example that we already had the derivatives to go off of. That's where I got these derivatives. I took them from 1 and 5. So you'll have to go through two derivatives here. So I would guess you'd need more space on this. I just wanted everything to fit on this page. So good luck, and I'll talk to you in class.